In this video, I'm going to solve a question about the position and velocity functions. A car is moving along a straight road from A to B. Starting from A, so from here, at a time when t equals 0. So the car starts from here when the time t equals 0. Below is the velocity plotted against the time. So the y-axis is your velocity and the x-axis is the times. How many kilometers away from A is the car at the time t equals 9? So imagine that this is the time t equals 9 where the car stopped around here. So we are asked how many kilometers or the distance away from the point A. Okay, so this is a problem about the position and the velocity. So recall that the velocity is the derivative of the position. So usually we let s of t to be the position functions and v of t to be the velocity functions. So to go from position to velocity, you need to take the derivative. And then to go back from velocity to the position, we take the integral. Okay, so in this case, we need to find the position of the car when the time is equal to 9. Now we are given the velocity and you are asked to find the positions. So that is the other way around. So you need to go back from velocity back to position. So you need to take the integral of the function. In this case, we are just looking at the integral or the area under the curve. So we start from the time t equals 0 and then you go all the way when t equals 6. We see that from 0 up to t equals 6, the velocity is above the x-axis. So this is the positive velocity. That means the car is moving to the right. Positive velocity means it's moving to the right from point A. And then by the time that it's reached to the t equals 6, then the car just stop at this point. 6 to 7, that means from the time t equals 6 and 7, the velocity is 0. That means the car is not moving between t equals 6 and 7. Okay, so how do I find the positions at the time t equals 6? Well, that is just the velocity, the integral of the velocity or the area under the curve or the area of this trapezoid. Now to find this area of this trapezoid, we use the formula, we add the two bases. So the base on the top has the unit from 2 up to 5, so that is 3 units. And then from 0 to 6, the bottom base has 6 units. And the area of the trapezoid, we take the two parallel lines, the two bases we add together, divide by 2, and then multiply by the height. The height of this trapezoid has the height of 2 units. So together you should get 9. So the area of the whole thing is 9. The area is equal to 9. That means when the time t equals 6, the position s of t, the position s of 6 is 9 units. 9 units away from the beginning, the point A. Right? So that is 9 units or 9 kilometers away from point A. And then the car stops from 6 and 7, and from 7 to 9, we see that the velocity, it has the negative value. And negative velocity means from 7 to 9, t equals 7 to 9, maybe here, the car just moves backward in the other direction, this way, because the velocity is negative. So you need to find the area under this curve and the x-axis, and this is a triangle, so the area of a triangle is 1/2 the base times the height, and 1/2 the base. You see that the base of this triangle from 7 to 9, that is 2 units, and the height from here to here, this is 1 unit. So we get what? We get 1. The area is 1. However, this is below the x-axis, so you need to consider that this is the negative value when you take the integral. So 9 is the value from 6 right here, and then we are not moving anywhere, and then we have a negative value for the velocity, so it's stack moving backward, so with the 1 unit backward. So the final answer is 9 minus 1, or 8 kilometers away from point A for the beginnings at a time t equal 9. So we are 8 kilometers away from point A.